So I have a known good running Jetta, but unfortunately I was misinformed. It's actually the 1.4 TFSI, not the 1.8. And I'm looking at actual values on this thing, and it's coming up in megapascals, but 14 megapascals is 140 bar. And that's what this thing's running at an idle. In fact, off idle it actually increases. 15, 18, 17, 18. Short-term adoption is at 0%. Long-term adoption is at 0%. This thing is running perfect. And of course it starts perfect. So I think I'm just going to change the high pressure fuel pressure sensor because I haven't found a simple way to check the actual high pressure fuel pressure. Maybe in the future if I can acquire one of those lines and TIG weld a fitting on the side of it just to put it in there for test purposes. So my thought was to try to jimmy rig a pressure gauge in there. I obtained another line. It's off of a GM product, and although the threads are the right size, the ball is smaller, so the nut goes all the way in and bottoms. So I took this line off, this high pressure line, so it goes from here down to a brace on the manifold. You see that screw right down there, and then down underneath. Now getting this line nut off at the bottom here, even when I was taking it apart, was a challenge. As I said, you got to take that line off because the manifold hits it on the way off. So I fabbed up a tool, and I've torqued this up now. I'll show you what the tool looks like. So it's a 17 millimeter wrench, but you can't get a flat wrench on it because you need 30 degrees. But with a box end with 12 points, you only need 15 degrees. So I fabbed up this wrench. I had a cheapy wrench, and I'll show you what the looks like. So I drilled the hole. I cut the wrench off about 3 inches long, 2.5 inches long. Slotted the opening so it goes over the tube. Drilled a hole in the wrench and pressed a 5mm socket in there that was junk, and so that I can put a 3/8 or 1/4 inch ratchet on it like that. And that worked quite well. I had to straighten it. It was the 15-degree offset was a little bit too much, so I straightened it. So that helped take the line off, but this fitting, although the threads are right, the ball is too small. So my intention was to put a couple of pieces of high pressure hose in there and a T and a 5,000 PSI transducer, but no luck unless I can find a different line. So it's back together, but I haven't run it yet. I've just turned the key on, and I decided to look at actual fuel pressure. Now with the fuel pump running, it's about 5 to 6 bar, and it says high pressure fuel is actually 6.6. What I'm going to do is I'm going to crack the high pressure line to bleed off the pressure now that the pump has stopped, the lift pump, and this should theoretically go to 0. This high pressure fuel specified value is desired, and this is the pressure control deviation. Let's see if this goes to 0 when I crack the fuel line. Well, I opened the fuel line completely to relieve the fuel pressure in the high pressure side. It should have went to 0, and it still says 3.6 bar. I'm going to do it one more time just in case I didn't open it enough. Okay, it should be at 0 now. I loosened the high pressure line, and it still shows 2.4 bar, which would be roughly 30-35 psi. So that high pressure fuel pressure sensor is skewed slightly, but it could be that it's not linear. In other words, it might be showing, it might be out worse when it's reading, reading 50 bar or something like that. Let's see how it starts. Okay, so I've had the high pressure line off. I'm graphing fuel pressure now. The green traces actual fuel pressure, which is 2.5 bar right now, and desired is not showing until we start cranking it. So let's see what happens. But the air pump is running, just shut off. So it's running about 200 bar, desired and actual according to this. Well, for what it's worth, I'm going to change that high pressure fuel sensor. I got no other way to qualify it unless I can find some homemade fittings to put in there. And I've got two pressure lines that are rated for 250 bar, and you can see that they would be stressed. It's not recommended to try to measure the actual pressure, but oh well. Let's see what happens when the sensor comes in. You can see once it's actually running and it comes down to about 88, 90 bar, the long-term adaptation is negative 39, 40. So it's running rich, or at least it thinks it's running rich. And if I disconnect the O2 sensor, it doesn't get any better. It doesn't seem to get any better. I disconnected both O2 sensors. So I'm thinking that the high pressure fuel pressure sensor is reporting higher fuel pressure than it actually is when it's cranking, and then lower fuel pressure than what we actually have. I got no way to qualify it, like I said. So I was thinking if there was a way to manipulate the fuel pressure, like some of these high pressure direct injected engines have the ability to override the fuel pressure, so I could increase or decrease the fuel pressure and see if it runs better. But it doesn't look like it has the ability to do that in the output controls. Fuel injector control, supply relay, fuel pump electronics, that just runs the lift pump. Secondary air injection, quantity control valve, is that it? That could be it. Let's try that. Well, let's see. Let me look around here. Well, I couldn't find a means of manipulating the high pressure fuel pressure. I don't think this vehicle supports that. Maybe if somebody knows it does. Looking at long-term adaptation at an idle now of negative 25, 30%. I tried adding propane to the intake and it got worse and stalled, so it's definitely not running lean. I never tried adding propane during cranking, but putting propane into the turbo is sketchy. I'd like to be able to introduce it directly into the intake manifold, but there's no simple way of doing that, because it's got to go through the turbo and through the intercooler. So I don't want to blow this car up, although maybe that would be a good thing. I just have to do it outside. Oh well. So this morning I decided to have a look at cam timing error, and you can see a desired and actual cam timing at 0. Other than cranking excessively long this morning, it started up. Initially the fuel pressure was around 60 bar, and then as soon as the air injection pump shut off, it jumped up to 200 bar, and now it's back down to 90. But you can see the long-term adaptation is at negative 20%. Although it's not running terrible this morning, it does seem to be running rich. Let's look at misfire counters. So there's the misfires reported over the last 1,000 revolutions. It's it's not really misfiring on any specific cylinder currently. It's just that the fuel trims seem to be clean. I wonder if it's actually, no, I'm just thinking aloud. I've disconnected the forward oxygen sensor and the back oxygen sensor, and it runs the same. I'm going to try one more time. So with the oxygen sensor disconnected and resetting the fuel trims, clearing the code, reset the fuel trims back to 0, you can see it's counting misfires on number 4 now. I watched a video last night on YouTube, almost exactly like this, and there was oil residue in number 4 cylinder. It's still not running very smooth. Well, we definitely have a predominant misfire on number 4. That's weird. According to this data anyways. So off idle, it still shows a miss on number 4. Try a little higher RPM. That's interesting. As soon as I bring it down to idle again, it starts misfiring on number 4. But that's in open loop with the O2 sensor disabled. It wasn't misfiring like that with the O2 sensor plugged in, but why would it affect one cylinder more than the other 3? So there's the new spark plug out of number 4. It looks clean. It's not fouled that I can see. There's the one out of number 3. Looks basically the same. And looking in the cylinder on number 4, and the piston's at the bottom of the travel now. Come on, get in there. The piston looks dry. I mean, it's slightly damp. I think that mark on top of the piston is from me touching it with the camera. And looking in cylinder number 3, the piston's at the top and it's dry as well. I'm going to switch the coil from number 4 to number 3 and the plug from number 4 to number 3. What is that mark on top of the piston there? Well, I don't see anything wrong. I'm going to do a compression test while I have those two piston cylinders out. I mean, the cadence of it cranking sounds normal. Okay, go ahead and crank it. Okay. So my gauge is still leaking a little bit, but it's about 140. Okay, this is cylinder 3. Go ahead. Okay. So it's roughly the same. My check valve on my pressure gauge is leaking. So I swapped the two coils, number 3 and number 4, and I swapped the two spark plugs even though they're new, and it's still misfiring on number 4. And that's in open loop with the air-fuel ratio sensor unplugged. Short-term adaptation, long-term adaptation, They're both at 0, so it's not making any fuel correction, but it's consistently misfiring on number 4 now. So this is, and I don't know if it's wishful thinking or not, but with that air-fuel ratio sensor unplugged, it seems to start better. I wonder if it uses the learned value during cranking. That's weird. I'm going to shut it off and restart it. Well, that's weird. So with the air-fuel ratio sensor plugged in and restarted, the short-term trim goes to negative 25% almost immediately. But you see it reduces the number of misfires on number 4, and now it starts misfiring on number 1, likely because it's running lean on number 1 too. So this is a really strange failure here. Now I'm not convinced that it's a high pressure fuel pressure sensor. But what is it? So I'm looking in the cylinder number 4 again after running it, and to me it looks oily. Let's compare that to cylinder number 3. And cylinder number 2. Why is it misfiring? See, that one's wet as well. Cylinder number 1. They're all kind of damp. But this one, number 4, looks predominantly worse, in my opinion. Let's look around in here. Let's switch camera views. Let's look around the sides. So there's the injector. Looking around the head gasket surface. Intake valve is partially open. So it's oily there. I was thinking of doing a cylinder leak down test, but I was also thinking of taking the oil pressure sending unit out and putting regulated shop air pressure into the sending unit hole. It's right by the oil filter here. Dialing up about 40 or 50 psi and see if we see any oil leaking into the cylinder. I did find a case of that. Let's give that a try. So I got shop air pressure connected to the oil pressure sending unit and dialed up to about 20 psi. I can't get any higher than that. There's too much volume leaks in the system. And I'm looking around the cylinder and I don't see any oil coming in. But that cylinder is definitely oilier than the other cylinders. Now mind you, when it's running, we'd have combustion pressure in there, compression pressure in there. Trouble is, I never cleared the fuel trims and noted the misfires before changing the injectors. Maybe I'm gonna do a leak down test and see if I pick up anything. It's definitely oilier in that cylinder. Why did it just freeze? Oh well. So I got number 4 on TDC with the intake and exhaust valves closed. Cylinder leak down tester on it. And of course it's not leaking anywhere. It's not. Valves are sealing. So what's going on in that cylinder? So I got the intake valves open again, and air pressure in the oil gallery, but I can only get it up to about 20 psi because of the volume of leaks. And there's oily residue in that intake port. See how wet it is right there? The other intake port is dry. I got like zero leakage when the valves are closed. So I'm wondering if there's a porosity in the head in that intake port and it's allowing engine oil pressure. I'm sure there's oil pressure in the cylinder head. I wonder if it's allowing oil pressure into the intake port and that's coming into the cylinder, adding to the fuel mixture. Normally it would run lean with a misfire, but that's an ignition misfire. There's definitely oily residue in there. Wow. So it's back together and running. You can see it's counting misfires on all 4 cylinders, but counting more misfires on cylinder number 4. Yet it's negative 22 to 23% long-term fuel trim. I'm going to close this, reset, clear the codes, and then go back and look at the data. Clearing the codes resets the fuel trims, if I'm not mistaken. Or maybe I got to shut it off. I actually have to disable the O2 sensor because the short-term fuel trim immediately starts correcting it. You see it's at negative 18, and then the long term will take over. Negative 20. So I think that there's oil leaking in. It seems to be leaking into the number 4 intake port, and that's causing a misfire on number 4, but it's not a lean misfire because it's not an ignition misfire. It's actually got extra fuel from the engine oil, I would imagine. And then it takes away fuel from all the cylinders, causing numbers 1, 2, and 3 to actually run lean, and then they start randomly counting misfires. So I'm going to have to discuss this now with the customer. I wish I knew the history on this vehicle because it was traded in, and this is the used car dealer that's trying to deal with this thing now. It'd be interesting to know if this was an inherent problem prior and Volkswagen knew about it, but we don't know. So I disabled the oxygen sensor again, reset the fuel trims by clearing the codes. Now you can see there's not making any correction, and all of the misfires are on number 4. So number 4 is missing consistently.